Let us discuss about the superposition principle. The superposition principle allows us to calculate the net displacement of a number of waves meeting at a point. That means two or more than two waves meet at a point with different displacements. The net displacement of the resultant wave can be got from this superposition principle. Let us take an example. Here we have a string in which two waves are traveling in opposite directions, one traveling in positive x direction, another traveling in negative x direction. Now they are meeting at this point. When they meet at this point, here is a flat line on this string. That means the two have superposed and have given a net displacement of 0. But after that time, these two traveling waves don't lose their individuality. That means their nature is preserved. That means after getting a net displacement of 0, this wave travels in x direction and this wave travels in negative x direction. It just gives us the net displacement at the point of meeting, at the point of superposing of the waves. We can see that if we are having waves, one wave having displacement of y1 x comma t, another wave having displacement of y2 x comma t. So when these two waves superpose, the resultant wave's displacement will be equal to y x comma t. That will be equal to the algebraic sum of the displacement of the individual waves. That means y x comma t is equal to y1 x comma t plus y2 x comma t. Now if we see, y1 is equal to f1 x comma t and y2 is equal to f2 x comma t and y3 is equal to f3 x comma t to yn is equal to fn x comma t. When these waves superpose at a point, the resultant waves displacement will be equal to y x comma t. That will be equal to the algebraic sum or the summation. That is summation I running from 1 to n fi x comma t. This is the principle of superposition. It just tells us that when a number of waves meet at a point, the resultant displacement of the waves will be equal to the algebraic sum of the displacements of the waves. To illustrate this superposition principle, let us take an example of two waves with angular frequency 2 pi nu and angular wave number is equal to 2 pi divided by lambda. So let the displacement of wave 1 will be equal to y1, that is r sine of omega t minus kx, and another wave y2 having the same amplitude but having a phase difference of phi, and that will be equal to r sine of omega t minus kx plus phi, where phi is the phase difference between the two waves. Now if these two waves superpose, then the displacement of the resultant wave will be equal to y will be equal to the algebraic sum y1 plus y2, that is r sine of omega t minus kx plus r sine of omega t minus kx plus phi. Sine a plus sine b is equal to twice cos a minus b divided by 2 sine of a plus b divided by 2. Taking it as a and taking it as b, simplifying it, it is just simple calculation. Y gives twice r cos of phi by 2 sine of omega t minus kx plus phi divided by 2. This is the displacement of the resultant wave. This twice or cos pi by 2 is the resultant amplitude. So we can say y is equal to r sine of omega t minus kx plus phi divided by 2. Let us take two examples. Two waves here having a phase difference of 0 and two waves here having a phase difference of pi, that is 180 degrees. Here we can see that these two waves get added y1 plus y2, and here we see that these two waves get subtracted so that the resultant is equal to 0. We will see it mathematically. In the first case, as the phi is equal to 0, so y is equal to twice r cos of 0 sine of omega t minus k x, as 0 divided by 2 is equal to 0. Now we know that cos 0 is equal to 1. So resultant wave's displacement is equal to twice r sine of omega t minus k x. That means if we have got two waves whose amplitude is r and r, when they have a phase difference of 0, their amplitudes get added, so the resultant wave's amplitude should be equal to 2r. If it is r and r, here the resultant wave's amplitude will be equal to 2r. Taking the second case, when two waves have a phase difference of 180 degrees, that means phi is equal to 180 degrees and phi by 2 is equal to 90 degrees. Now cos of 90 is equal to 0 and this whole term becomes equal to 0. So when we are having two waves of same amplitude, when they superpose on each other, when they meet at a point, the principle of superposition says that the resultant wave's amplitude will be equal to 0. If they have got different amplitudes, in that case the resultant amplitude will be equal to y1 minus y2. Thank you for your patience.